What's up, everybody? Welcome to Flux Harmonic. I'm David Wilson, and today we're back with another live stream where we try to create something cool from scratch. And lately we've been pretty heavily focused on this new programming language I'm working on called Mesche, which we'll talk a little bit more about in a moment. Today the goal would be to continue building out the Flux graphics module in the Mesche language. And for those of you who haven't really followed what we've been doing up until now, the overall goal, at least for the short term, is to be able to generate thumbnail graphics for YouTube videos using custom code, like basically from scratch, building it on top of OpenGL, writing the core of everything in C, and then using a Lisp-like language to drive the creation, both the interactive creation and the automation of creating these thumbnails. So it's been a pretty fun project so far. We've been taking a lot of twists and turns and circling around the same spot, but we're finally back to a place now where I think we're about to start taking big strides forward. Hello to Jackson and Daigo. Thank you both for being here. All right, so updates. This week, I've added support for cons pairs, lists, and backquoting in Mesche. So if you have used a Lisp language for a non-trivial amount of time, then you're probably pretty familiar with all these because the core data structure in Lisp languages is the linked list effectively, and they do this by something called cons pairs, where you have basically it's a pair of two values. There's a car and a cdr value, and then if your cdr value, the second value of the cons pair, is also a cons pair, then you're basically creating a chain of cons pairs, which effectively makes a linked list. So I added that support in the language this weekend, mainly because I needed it for, we kind of need it in general in a Lisp-based language, especially when you get to doing macros, but something I added now because I wanted to include that for the module implementation, which is the next big thing that got added. I basically added a module system for Mesche where you can define a module and do importing and all that kind of stuff. We'll talk about that in a minute, but really exciting because that makes it feel more like it's a real language where you can write units of code that are reusable. So I'm going to be spending some time on this stream building that out a bit more in terms of making an actual module for it, and then we might do some other hacking on that functionality to add some other interesting things to it as well. Another update would be that I'm actually thinking about participating in the Ludum Dare, however you pronounce that, the game programming competition on April 1st. If you don't know about Ludum Dare, it's basically a weekend-long game jam. There's a sort of concept of game jams, which are basically competitions to see who can make a game in the set amount of time, or who can make the best game, I guess you could say, in a set amount of time. I participated in this a couple times before in the past. It's a lot of fun. It's also very difficult, especially if you're coding nonstop for a couple days to try to make something. But the next one is on April 1st this year, and I'm considering doing that and possibly using a lot of the code we've been writing so far to create an entry for it. Now, I'm no artist. I have had collaborators over the years who are really good at art, but I'm not good at art, so I'll probably be doing this solo, and we'll see what we can cobble together. I might end up going to a website that gives free sprite art or something to put together a game. But honestly, that's not so bad. Really, the main thing is to just try to meet the challenge of creating a game in a short amount of time, and also to use the tools we've been building so far to sort of validate that they work for this kind of thing. Let's see. What are the rules, right? I just want, oh, really? 404 not found? Like the most critical thing you could have on your website, and it doesn't work. 404 not found. Okay. Mike Kasperzak needs to fix this. That's unbelievable. Event rules. That's really funny. Okay. So I can't tell you what the rules are right now. I don't remember exactly what the rules are, but needless to say, it is usually a 48-hour competition for solo developers, and I think sometimes they give a few more days to teams. Jackson asked a very important question that I should actually have mentioned while talking about this, which is I am planning to live stream it. So if the stars align and I'm in a situation where I can do this competition, I will be live streaming my work on it, which means there could be some fairly long streams on the Saturday and Sunday of that weekend. We'll see how it goes. I don't really know how easy it will be for my family to tolerate this kind of thing, but it's something I would like to try to do. because game development is a ton of fun, something that I want to do on this channel eventually, but right now we're just focused on more achievable goals, which technically speaking, we should have achieved some already. I guess we have achieved some goals, but really it hasn't gone much further than that. So anyway, Ludum Dare, I think we will do that on April 1st if everything lines up correctly for that. Okay, let's talk about the Mesche module system. So over the last few days, I wrote a new module system for Mesche that allows you to do the following, which is pretty obvious if you've ever used a language that has a module system before, which is many of them, almost all of them, I guess. Define modules in source files. So you have a source file, we've got some code that you're writing, and you can turn that into a module by using a particular syntax to define a module. Also, marking functions and variables to be exported from the module. So if you write a piece of code or a function or a variable that you want to be usable from other modules, you need to say that it is exported so that the module system knows to pick it up whenever someone imports that module. Also, importing symbols exported by other modules. So that's the other side of the coin, where when you import, you're basically only loading up the symbols that are exported by the module that you've been importing. The thing I should mention is that I don't have load path semantics implemented yet. Right now, it's all dependent on whatever gets evaluated into the code. I can show you an example of that. But one thing we might try to do toward the end of the stream, if we have time, is to start on the work to get load path based loading working. To be more clear what I mean about that, to be able to distribute code in modules, you need to be able to have a folder structure for modules, and that folder structure typically would correspond with the elements of the module name. So if you have a module called Mesche IO streams, then you would expect to have a folder called Mesche, a folder called IO, and then maybe a file called streams.msc, which comprise the contents of that particular module. And then all other modules in that same namespace would fit into that folder structure. So that's something we might try to implement a little bit later if we have time. It needs to happen soon, because if I'm going to have other dependencies I want to pull in from other repositories, which is a short-term goal of the language, then I'm going to need this functionality. So if I don't get it implemented partly today, I'm going to spend time over the next few days myself off stream working on that, because it's pretty necessary. So here's what defining and using modules looks like so far. And like I said, I'm doing this all in one file because we're sort of doing it at evaluation time effectively. So you can define a module using the define module keyword, and then you give it basically a list of symbols. The first symbol being the root name of the namespace of the module, and then any number of symbols after that being the sort of subnames for the namespace. So this is Mesche sample 1. Then you can define a value, or a variable with a particular value, and then you can use this export keyword at the end of the define expression to say that I want this value to be exported. If you don't want it to be exported, you just leave that colon export off. Same thing for function definitions. If you define a function, you use the same syntax for defining functions, but you can also add colon export after the argument list so that you say that this function needs to be exported. And just by doing that, it is these functions and variables are exported from the module and can be picked up by other modules that import them. I chose this approach for a couple of reasons. One is that the way that Scheme's module system works, or their library system works, you have to list your exports in the library expression at the top of the file. So you say what the imports are and what the exports are. And whenever I was writing Scheme code, I found that to be kind of a pain to keep that up to date. It's much better if you can express whether something is exported just on the declaration itself. So that's something that I wanted to do here. It is possible in Guile Scheme to do it at the declaration. They have a define public function or a special form or whatever you want to call it that allows you to do that. My child is showing me cornflakes through the window. Thank you. Anyway. So what was I saying? Yeah, so Guile does make it a little bit easier from that regard, but I kind of like the model that I see in JavaScript, where you have a function where you declare it, you can say that it's exported. So I'm taking a similar approach here to make sure that it's easy to export things right at the declaration. And if you were to remove this declaration from the file, or definition from the file, then the export also goes away. So everything is sort of co-located, and I prefer it that way. I'm defining a second module here. and then importing. I'm using this nested import expression to say I want to import mesh sample 1, which pulls in both of these two symbols from the mesh sample 1 module. And then I'm also defining another function here called toPrint with its own export. And then finally, I'm back in the mesh user module, which is actually the default module that gets created every time the VM starts up. And that is importing mesh sample 2, and then it's calling the toPrint function. Now, toPrint itself calls onePrint, which then does some extra stuff. And I can actually show you all this working if I run compile. Let's see, compile. Let's run lib/mesh/ what was it, sample/modules.msc. Let's run that really quickly. Okay, so ignore this panic at the end. I just need to fix a bug there. But right here, you can see that it actually does write out the string. It says this string comes from the onePrint function. Display string here, this is the parameter, and toPrint actually passes in mesh sample 2, which is this part that you see right here. And then there's this hello modular world, which comes from the string parameter that's being passed in from toPrint. So you can see that we're pulling in functions defined in a couple different modules, and everything works correctly. I had to deal with a little bit of scoping issues to make sure that the toPrint function is able to refer to the symbols that came from the module 1. But that's all stuff that was pretty easy to slot into the existing design that I had, since basically every function is defined as a closure. So basically you just add the module where the function is, or the module where the closure is created as part of the closure, and then when you call that function from somewhere else, you get back to all the original information from where that function was defined effectively. I know there's a lot of details, but if somebody wants some more explanation on that, I'd be happy to give it. So that's what it's looking like so far. I'm pretty happy with it. It's like it literally just got finished being implemented this morning. So there's bugs. We're probably going to run into them on the stream. So we're going to try to fix them when we find them. But it's all part of the fun, right? Okay, so for today's tasks, what we're going to do is finish building out the functions to describe the full thumbnail as we were doing in the last stream last Thursday. We had started to expand out the thumbnail.msc file that has a description for the Flux harmonic thumbnail. We didn't get it fully implemented yet, but we did get a couple things working, which is to load a font and to load the thumbnail images. In this stream, we're going to add the extra functionality necessary to register those things to be drawn on the screen. So we're going to get back to defining our scene as we were doing a few weeks ago before we started doing all this, new language stuff. And we should be able to get back to the point where we describe everything in the language, which we really never got to do fully in any of the previous iterations. So it's pretty exciting if we can get that working today. Also, we need to ensure we can dynamically reevaluate the full scene description. So as you're writing the scene, you need to be able to reevaluate parts of it to see the results on screen. And I think that we'll be able to get that done pretty easily, because everything I've been developing so far on the language should enable that. So I'm pretty happy to have that working, which also means we probably need to get the REPL working again, but I think we're in a good spot for that too. Hi, Robert. Nice to see you. And lastly, start working on load path support, which is what I mentioned earlier. If we want to be able to pull in arbitrary dependencies from Git repositories, we need to be able to load modules from file paths that we've cloned from Git repositories. So we may start working on the initial implementation of that as well. I think it won't be that hard. So I'm cautiously optimistic that we could get that going in a stream or two, or at least off stream. So for those of you who keep following the developments that are happening on these streams, let me know either in the chat or on the comments after the fact how much you like seeing stuff about the language development work, because I'm trying to do more of it off stream because I don't want it to be too boring. So let me know if you want to see more of it on stream, then I could probably try to include more of it in some of the streams coming up. However, I am kind of interested in getting back to working on more of the graphics functionality, like adding new improvements to things, making things look better, more capabilities, etc. Which, have a few ideas that we might get to on Thursday if we have time. All right, so let's get into the code. I'm not really going to go through a walkthrough of the module implementation because I think that it'd be better if we just start writing some code and see what happens. So if the goal is to get the Flux graphics module stood up, let's just take a look really quickly at what I have so far. So right now in main.c, I've got a little block of code here that is creating the Flux graphics module. So I've got an API for C that allows you to basically define a module and add symbols to it. Or effective. Well, let me explain a little bit more about what's really happening there. Here you have the mesh module enter by name function, where you give it a pointer to the VM where you're evaluating your code, and also the name of Flux graphics, or whatever the module is. This name needs to be the string representation of what the symbol list would be if it was inside of that sort of defined module statement. So here it's just Flux graphics with no parentheses around it. And I take that and I basically turn it into a string in the language and then use that to index into the module table that is loaded for this VM. Also, that we can use the existing mesh VM defined native functions to register C functions to certain name bindings, I guess you could say, like show preview window, etc. And I added a final parameter here at the end to say that this should be exported from the module. So this wasn't here before, excuse me, because we didn't have a concept of exporting. But now that we do need to have things exported, I added a parameter so that we can say that, yes, I do want this to be exported as part of the module that it's defined in. Now, we're not mentioning here in this function the module where this function gets added. The reason why is because anytime you enter a module, which basically means I'm making the current module of the VM, whatever it is that I'm saying here, when you do that, any global definitions are getting added to that module that's currently active, I guess you could say. So whenever you look at the code that I was showing you before, when you have defined module here, what happens is it either looks up an existing module called mesh sample 1, or it creates a new module with that name and then makes it the current module inside of the VM. And then any defines that are done here get registered to that particular module. So it makes it pretty effective. It also means that I don't have a normal global scope anymore. I only have module scope. So we start off the process inside of the mesh user namespace. So the first thing we do when we initialize the VM is basically say, I want to make a new module called mesh user, mesh object make module. I could probably use another function for this now, in fact. But we go into that module, and that's sort of like the first initial global scope or module scope. And then anytime you define a module, you're basically switching that to that scope inside of the VM, and then any definitions go into that module. So point being, it makes it pretty easy to deal with this idea of defining things in modules. But if I'm running this in a REPL, I need to make sure that I'm in the right module namespace before I start reevaluating function definitions. So that's something I need to add to the REPL code, so the REPL can be smart enough to look in a file and say, is this file part of a module, by looking for that defined module statement? And if it is, make sure that the VM is actually in the right module namespace before something gets evaluated. Jackson says, I think working on the language off stream and then covering the work you did at the beginning of the stream is a good balance. Of course, fixing bugs will probably need to happen during the stream. Yeah, that's basically the balance I'm kind of hoping to take, and that's what I've been doing the last couple of times, just making sure that it doesn't get too boring, because you don't want to like see a full language implementation written on stream unless we do it again some other day. Right now, it's not the right time because I'm learning as I go. Once I become an expert at writing, programming languages, then maybe we can do something on stream because I'll know exactly what to do. All right, so far in the Flux graphics module, we've got show preview window, render to file, this Flux harmonic thumbnail function, which is going to go away because it's sort of a hard-coded routine for drawing the thumbnail. Then also this font load internal and image load internal functions. So if we go back to look at our thumbnail.msc file, let me turn on scheme mode for that. We can see that we do have a couple of functions here that are actually meant to wrap the behavior in these native functions. So this font load and image load, we need to put this into a module. So now what we can actually do is start by saying define module mesh. No, that's not mesh. Flux graphics. And we don't need to import anything. And we're going to move these two definitions right up here. And let's see, define scene. I think also scene is what we want to put right here, because this is going to be a function we use for defining the scene lower here. So now I think what I'll do is also define a module for this thumbnail project. Define module Flux thumbnail, let's say. And this is more of a higher level module for just, rendering thumbnails. And we have these two modules defined in the same file. Ultimately, this is not my intention to have it be working this way. As soon as we have the load path stuff working, then I'm going to break these things out into their own files. But for now, this is how it's going to work. So let's see if I can run this. I'll run compile and then examples/thumbnail.msc. Let's see if everything works. All right, so undefined variable show preview window. Oh, that's because I did not import Flux graphics. So that shows that the module system is working as expected, because we don't have a global scope where these things are just, thrown in there willy-nilly. So now that I've imported Flux graphics and show preview window does work. So now we're back to having the previous behavior, which we saw in the last stream, where it does show the window. And we're basically back to the beginning. So we have our font loading that we were doing before, our background and logo image loading, and those two things, or those three things, I suppose, are really not that surprising. We're doing the loads, and that they actually do work if you look at the logs that are being written out. So now we are defining Flux thumbnail, which is really the key of all this, and we're calling the scene function, which is being defined inside of the Flux graphics module. So this is the point where we're going to start trying to build things out the way that I intend them to be. The sort of pattern that I want to follow for this is what I had in the basic graphics.fxs file, I think. So I had this idea of having the scene function that takes in the various things you want to render. And what I'll try to do is just move some of the stuff over and make it work effectively. So what we have here is scene, width, height, and members. I'm going to add members as one of the keys on this function. And then to call it down here, we will use members, just like we were doing in the example here. But I'm also going to use list. List is a new thing that I just added. Like I mentioned before, we do have list support now. And I can add image, I guess you could say. Like image is something that would be rendered on the screen. Image, name, background, and then X equals 0, Y equals 0. I guess we could just say it's going to be X and Y 0 on that, because it's just the background, just needs to be rendered at 0, 0 effectively. And then let's see, what else? That's probably it, right? Just for that image. We'll also add another image, name logo. And then the X and Y position, we probably need to consult the code that we hard coded on that. So let's go take a look at graphics.c. And let me turn on my keycast mode so you can see what I'm doing here. Is it not working? Okay, no, it's not doing anything, of course. Okay, so we're gonna go to thumbnail, and then we can go down to this part where we're rendering everything. So interesting, we're doing some math there, which is good because we actually have math support in the language. Draw rect fill. Okay, so we need to draw a rectangle also. That's something that I need to add as a thing here. So I consider all this to be in layers effectively. So the members list is going to be in order from bottom to top. So the first thing in the list is going to be drawn on the bottom, and everything else will be drawn as sort of a layer above. Not literally as layers. We may add layers later, but at least we're going to have the ability to draw things in a stack effectively. So draw arg scale. Maybe we need to have a scale parameter there, which is fine. Arg center. Okay, yeah, we need to have some kind of centering to say there. And then desired size divided by 2f minus 100. Interesting. Okay, so I got some code in there that I need to replicate, which is good. So the image itself, the background image is definitely 0, 0, okay? And then we have the logo, which is at this other location. So let's try to replicate a little bit of that and just see if any of this will work. I can fake out these functions a little bit here so that we don't have to worry too much about whether they are implemented yet or not. So context, logo, context, desired size. So width and height, we can just use the width and height. So X, and that's divided width by 2.0, which really don't need to, oh, I don't know if I have decimal support yet. I need to look into that in the language. Okay, so then width divided by 2 minus 500. So after you first do the division, you want to subtract 500 from it, and that should be good for the x-axis. Now for the y-axis, we want to do, so it's just, let's see, height divided by 5, right? I think that's what I had done there, okay? So let's just leave that rect out for now. So we have the two images. That should be good enough to start with. Inside of Flux Graphics, we're going to define those methods or those functions. Define image. Let's see, keys would be name, X, and Y. I don't know if we need name at all, but we're going to go with that for now. So keys, name, X, Y. Probably also need scale. And that should be it for that one. I'm just going to return a true here. We're just going to have a list of trues. It won't be a big deal. And then, yeah, I think that's good enough to possibly even try to run this. So let me try to run it really quick and see what happens. It won't render anything, but it will at least expected left paren after quote. Okay, so that's something I did not implement yet. Quoting of a symbol. So let me go and try to do that. So that's going to be in compiler.c, compiler.c, quote. Let's see, list starts with a quote. Let me get rid of this little frame here too to have a little bit more space. All right, so I'm looking for the quote right here. So parse quoted list. Now, really should be parse quoted expression. And this is a problem. We're looking for an open paren. So we probably need to check and see if the next thing is a symbol, because we really just want to be able to parse a symbol literal in this position. So if context parser current dot kind equals token kind symbol, then we can just eat that symbol. Let's see. Yeah, I think we just want to have that parse as a constant. So compiler parse symbol CTX. We also need to advance the parser, compiler advance CTX. And the reason why is because the parser operates on a stream of tokens that are coming in, and a lot of these functions that create new things are based on the previous tokens. So we have to advance the token one, sorry, advance the parser one token ahead, and then run the function that takes care of whatever it is we're interested in. So in this case, we are basically just saying the next thing's a symbol. So let's bail out after that, because we know that we're done. If this is a quoted symbol, just parse it and return. Okay, so let's see if that works now. Compiler error. Okay, too few arguments to, let's see, compiler parse symbol. Let me see if I can run. No. Compiler parse symbol, right? Symbol right there is global. Okay, so I don't want this to become a real symbol. I want this just to be a literal that gets turned into a constant. So parse symbol a literal, and then I might need to write out the code to consume that. Let's see. Compiler parse string literal. We make the string, we just return it, and then we can emit the constant. Okay, so maybe I'll add another function here for parse string constant. So let's just jump ahead to literal here, and then constant. Oops. Code formatter's doing some freaky things. All right, so now I can just call into compiler parse literal string. Come on now. There we go. Great. Ever since I updated Corfu and Eglot, things have gotten way better. So I think that some of the issues I was having have been fixed now. So we're gonna take this as object symbol, symbol, and then compiler emit constant. And what this is gonna do is gonna push that symbol into the compiler so that it's usable as a symbol and not as a variable that gets resolved. Parse pilot. Whoa. Parse. Yeah. Okay. String literal symbol literal. Am I doing the wrong thing here? What's that? Parse string literal. Parse symbol literal. That's a function, right? Okay, apparently I screwed that up. In fact, I need to put this below. Okay, so string constant. Wait, hold on. I'm already doing that. It's right here. Forget it then. Don't need that. Okay, so parse symbol literal should do it. So let's go back where we were before. Right to, oh, come on. What function were we in? We were in quote list, quoted list right here. Parse symbol literal. Okay, that's what we need. That should work. Okay, cool. So it did run the code, which is a good sign. It means that the compiler didn't have any issues with the code that I tried to load up. And if we go look in the code a little bit, the generated bytecode, I think we will see that we have, what is it? What are we looking for? The name BG dash, or quote BG here. Yeah, so that we have a constant for that there, which is a actual symbol constant. I should probably write that out correctly too. Jackson says, I don't know if you talked about this yet. Are you planning to bootstrap the compiler or just leaving it in C? Or I guess, is there any benefit to bootstrapping it? So I have a long-term plan to do some actual bootstrapping. Very, very vague plan, but the idea would be that eventually if I could do some form of just-in-time compilation to native code, then I could conceivably bootstrap a full compiler binary using the language itself. But that's like long term. Really, the aim of this language to begin with is to be symbiotic with C, because that means that it can go anywhere that C goes, and also it would make it very easy to interact with, you know, high performance code. So at least for now, it's mainly like meant to be used with C as part of a C program. So I think that's the way that I want to keep it for a while. We can definitely get to bootstrapping at some point, but for now, this is the most effective way to use it, I think. All right, so so we've got this working where it actually parses all of this, including the keyword arguments, which is great. Also, this stuff seems to have evaluated correctly, or at least to the extent that it did not crash. In fact, we can look at the bytecode and see that it's doing those operations. So I think we have like a divide. There's a divide here. We're dividing the constant 2 by 500. So, oh, we're dividing 2 by the global width. Whoa, global? No. Oh, yeah, it is a global. That's right. Okay, so that makes sense. Cool, so everything's good. Now, we just have to implement this behavior, actually. So there's 2 things we need. First of all, the scene needs to be able to enable the scene. So running this function, well, no, that's not actually true. I think we want to have another function for that. What was I calling it? Render graphic? Trying to think of the right way to do this. The ideal goal would be that we may not even need this defined here. What we may need to have is like a render scene, and then have the scene be defined as part of it. But we don't need that, actually. We can just have render scene here, and then have Flux thumbnail be the variable. So render scene should probably be defined here. Define, well, actually, I want to go scene render, because I'm trying to use this more noun-centered vocabulary. So scene render Flux thumbnail. And scene render should go and make that so. But the question is, if you're doing this dynamically, or let's say you're doing it interactively at runtime, which part of this are you going to be evaluating? I think you would just be evaluating this whole scene definition to replace the existing value of Flux thumbnail. So how would that work in practice? If you replace the value of that, then scene render would be kind of watching potentially this value, this variable. But you can't really do that because scene render is just getting the result of Flux thumbnail. So you may have to run scene render again for this to work. So it could just be that wrapping this in scene render is the best way to approach it, because then anytime you evaluate the outer expression with Control-Alt-X effectively, then you automatically get the new scene rendering. So we'll stick with that for the moment. We're just going to leave that Flux thumbnail variable defined out of it because we don't really need that yet. We could use it later, though, if we're not doing this interactively. Okay. So we actually could use a defined scene as well. We could define our own defined scene function that takes care of doing both things at once, but that's for later time when we have macros, I think. So we can run the scene render function with the result of the scene function, effectively. Whatever. Since I changed this from a define to something else, it changed the indentation levels. That's fine. So now we need scene render as well, which takes in a scene. And then that needs to do something. Display rendering a scene. Let's try that out really quickly. And we probably would see rendering a scene. Oh, interesting. Did it show up, did it? Let's see, rendering a scene. Defining a scene. Interesting that it didn't actually write those out. I wonder what happened. There was no error. Oh, hold on. Undefined variable font load. Font load. Ah, okay. I'm not exporting these. Interesting. So that's showing that exports are working as intended. Okay, so we want to export that as well. We want to export this, export this, export this. All right, let's try this again. All right, defining a scene, rendering a scene. That's written there now. So that is working correctly, which is great. Okay, so now let's remember what we were doing before with scenes. Probably a month ago. How long ago was that? It was a while back. We'll go into scene.c. We had some functions in here for making structs and blah, blah, blah. We might get back to using some of those, actually. Add scene member. We were using that from the scheme code originally. We were using Guile scheme for all of this, and we were calling add scene member. We had a type for the scene object. We had a property list. I might have to change the design of all this because my understanding of a lot of stuff has improved since then. Let's check for scene here. All right, type circle, color type, circle type. All right, so we have a type and we have a props list. Let's see. How would I change all this? I mean, may make more sense to use like a tagged union instead of all these pointers. But we can kind of continue with what we were doing so far. Let's see. Flip current scene. Promote staging scene. Yeah, we had this idea or this concept of staging scenes where you've rendered something to a background scene and then you flip it with the current one so that it makes it active. So the function which renders the scene, probably what it will do is just flip that. So I think if we were to call something, we would be calling, let's see, what was it? Promote staging scene. Promote staging scene. We may still have some code actually from the old implementation. Source modules, Flux graphics. What do we have in here? Take a look at the old scheme stuff we had written for this. So this whole foreign library function thing is something I want to get back to with Mesche. So we're going to get sort of back to what we were doing before, where you could dynamically bind to the functions in C, but that takes a little bit of effort, so we won't really get to it anytime soon. Probably, you know, let's say in a month or so. Until then, we can write our own wrapper functions. No big deal. All right, show preview window, render graphic. That's what I was calling it back then, render graphic. Make scene, promote staging scene. Okay, so make scene. What does make scene do? Is that in graphics.c? Make scene? Probably it's in scene.c. Make scene. Whoop, make scene. Where is that defined? Make scene. Scene members, process scene member, pretty print scene members. Process scene member. Okay, so it's basically using some code to check what type of member it is and then creating the objects in the background. All right, so at this point, I don't think I would do it the same way. The reason why is because now that my language has the ability to garbage collect C pointers, we could just do the allocation for the scene member directly in these functions. So let's say we go back to thumbnail.msc, we have image, we have scene even. We could do all the allocation of everything directly. Hey, Emil. And then let the garbage collector take care of freeing all that whenever it's necessary. But I guess the question is, do we know how big the data for the C pointers are so that we can factor that into our calculations? That's one thing I may have to consider. So image would create the instance of a scene member to display an image. I might just rethink all of this stuff because what I did so far was kind of lame compared to what I would like to do. So we may use some of it, we may not use it, we'll see. If I were to think about this completely fresh, what I would do is have a C struct for displaying an image. And it could be a tagged union type situation or similar to what we had before. So it's just something you allocate in C, a C struct. You populate the information in it using the parameters that are passed into the mesh function for that. And then you return it. And when the scene gets constructed, you're passing it a list of members. So the member list would be used directly to construct the new scene itself. And then when you call scene render, that would just directly take that scene object and make it the current one being rendered. We wouldn't need this idea of staging scenes anymore because we would be able to switch out the old scene, just basically not use that object anymore. But the problem for that would be, how does that get garbage collected? How does the language know to get rid of that object? Maybe there needs to be something holding on to that, like potentially a current scene variable that's hidden inside of this. That could be useful, I guess. So scene render might have a variable here, like let's say define current scene nil. And then when current scene is holding on to that scene object, then it will not get garbage collected. But if the current scene gets replaced by a new scene, then that scene object could potentially be garbage collected at some point in the future. So we could do that for now. Define, or let's say store the current scene so that it doesn't get garbage collected. And we are not exporting that, so that will not be accessible to other modules. It's just there to help with memory management. Okay, so let's see. For image, let's just think about what we would do for image. We'll go back to scene.c, or in fact, maybe even flux.h, and take a look at our data types. So we have a scene type that has a member count, a number of members. We may actually change that now because we have data types that can help us. But I probably need to add an array type or even a list. A list could be fine. So it could be a const list. Actually, it is a list. We already have that. So how about this? Object cons. I'm going to have to put, oh, Mesh is already in there. Cool. Object cons, members. And that's basically our linked list of members in this case. So we don't even need member count anymore. So we have scene type, object cons, members, which is good enough. Now, the other question about this is, how does this participate in garbage collection? It's kind of a tricky subject. If you have C structs that have pointers to objects, and that C struct is the only place where that object is pointed to, how do they participate in garbage collection so that this object const is not collected? It's almost like you need to have a special collector registration function for a scene type, or you basically make it its own struct, which is problematic because I don't have the ability to define structs in Mesh yet. And even if I did, accessing them from C would be a problem. So I do need to have the ability to access those in C. So I'm trying to keep it so that well, I guess one way to look at this is the C data structures may need to just be their own thing. Meaning no interleaving with mesh objects, because this is going to cause problems. So maybe I do need to have the previous design. So let's stick with the previous design that we had so far. Scene member type. So that's the actual scene member object or struct. We have this circle stuff here, but we don't really need that right yet. Type def, struct image type. So I probably want to call this like scene image, scene image. And what do I need to hold on to here? I need to hold on to a Flux texture, I think. Which begs the question, why have I not added the ability to point to a texture yet? I definitely need that here. This is something that's needed. So name texture. I suppose I could have a file there instead of having the texture, but it'd be nice to make it possible to reuse an existing texture or image. Image load. I'm calling them images here. So maybe, it's a little bit redundant to call it image twice. We'll work on the terminology at some other point. So texture BG image. How about that? And here we're going to say texture is logo image. Okay, so that's something we definitely need. So back in flux.h, we need to have the flux texture, which is a texture, which also is a pointer. And then we need to have the position, which can be a vec2 position. I think that class should work here, right? Yeah, all right. So vec2 position, unknown type name vec2. Do I have the, what is it called? Graphics.c. Let me pull that library here. CGLM is the one I want to pull in. Let's pull it in right there. Vec2. So that's like a really good math library, and you can do things like encode vectors and matrices and all that kind of thing. So I'm going to use that for anything relating to positions. All right, so we have vec2 of position. We have our texture. We also have a name, but I don't know that that's necessary. It may be something that's stored only in the mesh layer. So texture, X, and Y. That's the most important things for now. Back in flux.h, just double checking what we have for our image type. I'll say scene image type. And then I need to define a value for that one. Let's use an enum instead of what we were doing before. So enum scene member type. Type circle. I don't know what I was doing before. Type none. Yeah, type image. That's good enough for that. Let's get rid of this type circle. My understanding of how to design C libraries has improved a lot since I've been working on a lot of this stuff. But I'm still not perfect, obviously. So if you have suggestions, please feel free to let me know. Okay, so we got scene member. Scene member stores a type, which could actually now be a scene member type instead of this scene member type. The properties. Yeah, I would change the way that I do this entirely. So how about we do this instead? We're going to change this data structure to use scene member here instead, member, because this sort of nested struct concept is much easier to deal with than what the weird thing I was doing before. So now any scene image is actually going to contain the definition of scene member, which means the scene member type is going to be a part of that. So we can sort of treat them interchangeably to some degree. Scene images is effectively a substruct of scene member in this case. What don't you like here? Must use enum tag to, oh, okay, I need to type def that enum, I forgot. All right, so type def. Let's just put this here like that. I've also been hearing a lot from various sources that type def is bad. So I might need to rethink my usage of type def, but I'm not going to do that right now. Okay, so scene image, scene member, scene member members. That's good enough for that. Member count. Okay. So now that we've got our basic data structures figured out, we can possibly start implementing some of this stuff. Don't need these externs. That's one of the things I've also realized over time. Don't need externs on these. Or shouldn't need anyway. Okay, and now if I were to make a function, let's say a scene image, flux scene make image. So Ashra says, now you have a scene member type def from an in enum. Oh, you're right. Thank you. I haven't gotten to compiling this yet, so yeah, let's get rid of that one. Thank you for pointing that out. In fact, let's just get rid of that entirely. We don't even need this the struct name. Let's use the word kind instead of type. That's one thing I've been doing around in various places. Thanks, Ashraz. Okay, so now that's a little bit more happy. So flux scene make image. So what we'll do is flux texture. We're just going to pass in the parameters that we know of already. Let's say double X, double Y. Probably going to regret that. Yeah, Ashra says it would have been fine since one of them is in the struct scope, whereas the other one is in the global scope. That's right, but you still probably don't want that kind of mess around. Yeah, the human compiler is going to get confused. And there was a marker on that that member of the struct, so I think that would have been a problem at some point. Or at least it would have shown up as a warning, I think. Okay. Make image. So what am I using for allocations here? Alloc. It's been a while since I've used the APIs in this project. So I'm not using malloc. I want to use flux memory alloc. Okay. Flux memory alloc. This needs to be moved to another file. Let's drop this into scene.c. Make color struct. All right. Let me... So much crap in here. Let me just drop it at the bottom and we'll start aggressively deleting things pretty soon. All right, flux.h. I'll take this out so we can have that function scene make image. The idea here is that the scheme API or the mesh API will be able to call into this function through a wrapper and then get a handle back to this direct object. So that would end up looking like, let's see, where were the other functions defined? This graphics, no, it's even in here, func. Yeah, that one, okay. Flux scene, func, image make. Yeah, that's really nice juxtaposition here. So mesh APIs, API wrappers, let's call it that. Okay, so for image, we do need some of this information, but it comes in the form of args, so we don't have to, excuse me, we we don't have to worry about specifying those directly. I'll talk a little bit more about how the keyword stuff is going to work in a sec when we get to that. So let's go to scene.c and paste this in. And wow, what is a code formatter doing? Why would you ever? Probably it's because I didn't have a semicolon at the end, right? Yeah, of course. Okay, anyway, this wrapper function is going to try to call into Flux scene make image. And it's also going to call, let's see, mesh object make pointer. It's going to cast that to VM, which, you know, it's not a really good pattern. I need to fix that pattern a little bit because it's kind of nutty. All right, what else do we have to put in here? Void pointer, that's going to be the image pointer. And then is managed. So I want to make this managed by mesh and its garbage collector. So let's put that there and then fix it. So then scene image equals Flux scene make image. And then we're going to pass in the texture, the X and Y positions. Now, to get those, I need to look into the args list that's being passed into this function. So let's go find another one of these funcs and remember how I'm doing that. Font internal. All right, here we go. So this is basically what we've been doing before. That's the pattern we've been using for digesting what's in these. And func image make. That one is going to be called internally to the image function here. Image make internal, I guess you could call it. I don't really know exactly what we call that. So there's image load internal, image make internal. Kind of cheesy to have both, but honestly, it's not really image in the sense that it's an image. It's like the scene member. So it's like a scene image make. And we need to pass in the texture, the X and the Y, and possibly the scale. I mean, maybe I should just go ahead and do that anyway, because we're going to need that at some point. Okay, so now we need to register that function. So we're going to also rename this so that it's clear which one we're talking about. Scene image make. We're going to go back into flux.h and make this also scene image make. And then we're going to go to main.c. We're going to have to fix this up a little bit at some point because I need to reuse these definitions elsewhere. So we're gonna have to come up with a pattern for replicating native function bindings in a more convenient way. Like having to call this function repeatedly also is not very good. So we'll figure that out in a second. Scene image make. All right. And then if I jump back to this scene image make. All right, so that scene image make function is now should be visible. This doesn't seem to like it. Oh, it's because I'm putting it flux texture. That's wrong. So flux scene. All right. So now we have that function registered. All I need to do is finish implementing this part. So right now let's say do we require 3 parameters, 4 parameters? Let's say we do, because this is an internal function anyway. We're not going to export this. It's going to be used only internally by the module, which is going to be a cool property of this, which means we can sort of bind C functions into the module, but not export them so that other modules can't actually call directly into them and do bad things. I guess you could if you were sufficiently motivated, but we're not going to worry about that right now. Okay, so first of all, what are we returning with the... Let's see, that's probably in graphics, right? Func image. Where's that? Func image. What? Image load. Flux texture func image load. Yeah, that's the one right there. And we are creating a pointer just like that. So it is going to be a texture we can pull out of that. So let's let's see, this is which function now? Show preview window. I want to get back to scene.c, and then here at the end, we're just going to copy. Oh, I've already basically done the same thing here. So return, return object val. Okay. So the texture we need to pull out, we're going to pull out the object pointer, texture pointer equals as pointer args 0. Whoops, that's not 0. And then value x. Yeah, just x, I suppose. X pos x. Which way do we want to go with that? As number, I think, if that's one of the functions I have. As number args 1. Let me go double check on that. As number, is that real? Let's see. And then we'll do position y as well as number 2. We'll just delete those and then see what we get with this. So let me check value.h really quickly. As number. Hey, gun. Okay, as number is good. Cool. Value, pos x, pos y. So we can drop those in right here. So pos x, pos y. And I probably need to pull out the value of that. Oh, is this? It's not right, is it? So this is going to return what? A double? Oh, okay. It'll just return a double directly. So double pos x, double pos y. There you go, proof. Now, let's see. We just need to pull texture out. So texture pointer. We're going to cast that to a texture. Texture equals texture pointer. Okay, so we're trusting that this is actually a legitimate object. Use of undeclared identifier texture. Is it Flux texture? Probably, yeah. Flux texture. Okay, so that code looks happy now. This font is not supposed to be there. So now this would create a scene object, or at least it would call into this function that should make a scene object. I mean, you may be wondering, why should we actually have this separate function here? Is debatable. I mean, if the API is only meant to be used from within Mesh, then it would make sense to only have the Mesh API, but we're gonna do this for cleanliness sake for now. All right, so scene image equals flux memory alloc. Man, language server is just not helping me right now. Flux memory alloc. Just make sure that I remember how to call this. Just a size. Okay, so size of scene image. Nothing special in scene image. We can just give it straight the size. So we allocated the imma. Okay. Let's see. Okay, yeah, right. So then we can return this image in the end. We also want to initialize it. So image texture equals texture. Hey, Fikri. And then image position. Now, I'm not sure the way that this vector class, I can't remember the specifics. I think it's actually an array, effectively. So 0 for the first one equals x. And then for the second one is going to be y. Okay? That should be right. Let's actually try to run this and see what happens. Okay, so new member type. Scene member has no member named type. That's in line number 69. Okay, so some of these things we're just going to, comment them out temporarily because they're really not necessary anymore. And if they're causing compiler errors, then forget about it. Mesh object make pointer, undefined reference, 142. Mesh object make pointer. I'm pretty sure that's part of the Mesh API. Let's go back to object.h mesh make pointer. Make pointer is there. Let's see. VM pointer is managed. Okay. Undefined reference. I must be missing something. In function flux scene func. This is in the linker. Something wrong is happening. It's not having problems with other types, I think. Because I'm calling other things from the Mesche library. Undefined reference. So it compiles, which means it finds it in the header. Make pointer. I was using it, where was that? I was using it in texture.c. Texture.c. Yeah, make pointer, right? Let me just make sure I didn't typo that somehow. No, that's right. How could this library not have it and the other one does? Because I don't have mesh.h? No, that can't be right. Very strange. But if let's say I take this out and return null. If the code still builds, and we know we have another reference of this somewhere. Okay. Nil val. How about that? Ashra says, require Ashra's live linker. Yeah. Okay, so obviously... Please show the definition of mesh object make pointer as well as its declaration. So let's go into object.h, and you can see the declaration here for mesh object make pointer. Nothing special there. And I'll remind you that we are using the same function somewhere else in the Flux code, so it doesn't make any sense why all of a sudden the linker doesn't like that one. Then also in object.c, we have make pointer right here, and nothing special there either. It's the same as pretty much every other function we have in this API. So, and we're using that in texture.c with no problem. Let me go back to scene. Did I take that back in? All right, let me try to rebuild this one more time. So let me just think about this really quickly. In lib, we have cmake lists. Scene.c is included. Inside of the normal cmake, let's see, lib, add library mesh. Flux compose pulls in mesh, but does the Flux library pull in mesh? No, that's probably why. I'm kind of curious why that ever worked. So the Flux library also needs to pull in mesh, I think. It needs to link against it. Let's try that. Yeah, okay. Obviously that was a problem. Kind of weird though. Weird that it had worked before, or did it ever work? I guess that's the question. Maybe we never hit that code path after all. We'll put mesh a little bit ahead here. Okay. Now, let's go and let's see, what am I thinking? We're going to go back into scene.c. That should have actually worked now to create that object. Let me get down to right here. Printf created an image or a scene image. A scene image. We're going to put a pointer format specifier here because I want to see that it actually does have a pointer that doesn't look bogus. Image. Okay, let's just roll this back really quick. All right. All right, created the scene image. That looks fairly legit. Yeah, I think it's probably fine. So we have both of those that seem to have been created, which is great. And the GC seems to be freeing those pointers, which is also good, but I need to add some extra logic on that because I think I'm not doing a good enough job of it. All right, so now I need to create the scene. So if I can make the scene, I'll also need a function called scene make, I believe. So scene make, num args, blah, blah, blah. What does that need to have? Whoops. What does that need to have inside of the MSC file? So scene keys, width, height, members. So the width and height dictate what the actual size of the image should be. And then you have the member list, which is just a list, and it should have a list of pointers that came from C, which is great. So here we'll do a similar thing where we check the arg count. We just, I'm just going to rip off this code here because it's a pattern to follow. The number of arguments will be 3. And we can say function requires 3 parameters. And then the first thing we're going to grab is the width. So we can just scoot these down a little bit here. We can say width and height. Width, height. Come on, there we go. Height y as number args 0 and 1. I think that's what we're going to be passing here. Also say scene make as well. Scene make. Probably need to say internal also in there, but let's just leave that off for now. Okay, so width, height, members. Okay. And then scene render, we'll get back to that in a minute. I'm surprised that actually did anything. I probably got an error somewhere, I just never saw it. Scene render, let's just return true. That's good enough, I think. All right. So now we pulled in this stuff. We also need to pull in that list of members equals as const args 2. And it's a const because it's a list, basically a linked list. So flux scene make. Now, we have the list of members as a linked list in terms of mesh. But to put the members into the scene object itself, I had something up here about initial member size. I think I was like pre-allocating, okay, the list of members. Interesting. So what I might need to do is have another kind of flexible array implementation, which I'm not going to deal with right now. Let's just stick with this whole initial member size thing and leave it as it is. Add scene member. We could probably restore that. But the problem is the design is a little bit different than it was before. And now we're actually allocating these scene member objects and not putting them at specific slots in an array. So it does sort of, indicate we might need to have an intermediate representation if we want to keep the same design. However, for simplicity's sake, it's probably better to go with something less pre-allocated, I suppose you could say. So, honestly, shit. I'm trying to think of the right way to accomplish this. We can copy the value of the member, but then we have to get rid of the object that was created. In theory. Yeah. So let's just go with this for now. I think I'll do the copying first, and then we will go back and try to fix this later. So scene image make. We actually, we could find out how many scene members we have, and then allocate only that much, which would be kind of nice. But scene image flux scene make. Let me make a function for that as well. Something like that. Let's just copy this so that we don't have to retype some of the stuff. All right, so now I'm going to create a scene. Flux memory alloc. Oh, wait, I was creating a scene somewhere else up here. So where is it? I have a function for that. Init staging scene. I don't really need those functions anymore, but I do need the similar logic. So how about I do this? No, not that one. Scene make. Right. This is the place to be. Yeah, make scene. Let's make a scene. Okay, so here we are. Scene member count is 0. Scene members is malloc scene member times initial member size. Now, it's not exactly right. because all scene members are not the same size, so they're not going to fit in this array. It's almost like we need an array of pointers to scene members, which is even worse in terms of performance. But let me get rid of some of this stuff here and think about it again for a second. I don't want to spend much time on this because it would be nice to get something working. Yeah, it could just be a list of pointers. And if I do that, the problem is that that list of scene members is not going to be stored anywhere, and the GC may try to reclaim them. But if I tell the GC not to manage scene members, then the internal system can then decide when things need to get deleted. So that is a possibility. So how about we just do that? We're going to make this a little bit messy for now, and then we'll clean it up later, as I've said like 3 times already. All right, so size of scene member star by initial member size, okay. And then the member list needs to be a, let's see, where is it? Scene, no, flux.h. So for a scene, the members list is going to be a pointer of pointers, because we just basically have a dynamically allocated array that then has pointers to scene members in it, okay? So now we have Flux make scene. We don't need this texture stuff in here anymore. We do need width and height, I believe. So is that part of the scene? No. Interesting. Well, let's add it. Double width, double height. And they're doubles because the integer type in Mesh is doubles right now. I mean, we could make it integers if we wanted to, but we don't really have to. So double X, double Y, we'll say scene width. No, that's wrong. Equals width. And then scene height is height. All right, so let's go here and change these as well. Width and height. Okay. So Flux scene make. Alvaro says we've achieved the double asterisk quality milestone. Is that indicating that the quality has now gone down because we're dealing with the nebulous mass of pointers? All right, so Flux scene make. Let's get rid of this and then throw in the width and height. So we're gonna have to do a little extra work here because we need to loop through the list. So what we're going to do is, let's see, I need to loop through the const list. So object const current equals members while current is not equal to the empty val, because any list is going to end with the empty value and not a null. So there's an empty list value. I'm sort of taking that idea from Scheme where lists end with an empty list, which doesn't make a whole lot of sense, but I can show you a little bit more about that at another time. Okay, let's fix that really quick. So if current is not equal to the empty val, that's actually not right. Current cooter. Yeah. Then, well, we need to do something else first. Well, there's another place where I've actually done this kind of loop. Empty val. I think it was in modules.c. No. What did I do in module? Whoops. Is cons. Okay, while it's still a cons. Okay, that's good. That's actually a better check. Isn't, yes, I think you might be right about that gun. In common Lisp, I think an empty list is equal to nil, but in Scheme it's not. It's a different type entirely. So the empty list is its own unique type. And that's something I've been carrying forward here. So current, well, current cooter, list as const, list cdr as const. Yeah. But I had to do something with that value first. Yeah, the car first. Okay. So maybe this needs to be more like a do while instead. Because we assume we're going to have a car first. And then we could say current equals as const list cdr. But we also need to check and make sure it's a const. We'll do that another time. So now, with the car value of the current const cell in this linked list, we need to pull out the scene member object pointer and then add it to the scene. So if I have a Flux scene member add or push, I guess you could say even, scene would be a parameter, and then the pointer to the scene object, which in this case would be an object pointer, member pointer equals as pointer current car. Now, in this Flux scene member add, I want to just pull in the pointer directly so I can cast that to a scene member star pointer. And then say member pointer. And that should do it for adding that. I just need to add that function. So Flux scene make, what don't you like about that? Flux scene make is undefined. Flux scene make scene. Okay, fine. And then Flux scene member add, we need to go back and add that. I'm just going to put it right here because why not? Void Flux scene member add Flux scene scene member. So then in the list, we're going to say scene members, scene member count, I believe. Language server is not helping. Let's double check that. Member count, okay? Let's also do this. So scene members, member count equals member. Is that right? Okay. And then scene member count plus plus. I suppose I could do that inside of here too. Maybe. But let's just leave it like that. Scene member add. That should be good enough. Flux scene unknown type. Probably it's just scene because I didn't put the right prefixing on there. Okay. So Flux member add scene. Use of undeclared identifier scene. Did I not create that already? Flux scene make. Oh, okay. How about this? Scene. Where's the image function I added? Because I want to delete the stuff that I already wrote. Okay, good. Scene image make is there. Yeah, in Gael, nil is definitely distinct from empty list because they're different types in Scheme. I verified that by reading the Scheme spec. I am sort of tracking Scheme a little bit because, you know, it's better to be somewhat consistent with the existing design of Scheme, even though I'm not going to be 100% consistent, not even close. All right, so Flux scene member add. All right, so make scene scene. All right, cool. That was the last thing I hadn't updated yet. Add the member pointers to the scene. So here's sort of the moment of truth, I think, of whether we can actually generate a scene object based on what we have here. And for the member objects, I think I don't want false. I don't want Mesh to try to GC these. I want the scene to be the owner so that when the scene gets freed, it can free up all of the scene objects. However, that could be problematic because let's say you decided to design, yeah, maybe that's not good. If you define scene members as part of your, as a variable, let's say, inside of your document, and you reuse that inside of the scene, which is very, very conceivable, then you don't want the C layer freeing those out from under you. So you want to be able to have the mesh layer take care of that. Okay. So that's good. Let's go and, well, no, we got a couple more things to do. I think we need to go and register the scene make function. So, and also, do we have that in the flux.h? No. We got to do this. This doesn't necessarily need to be, okay, let's just do that. Scene make scene. We'll fix these parameters, double width, double height. Okay. And for this one, that's all good the way it is. And then we'll go back into main.c, copy that, scene make also, flux scene make. Okay, and we do not want to export those. Let me make those false. Those are just internal methods which should not be exported. Even those should not be exported, so let me fix those as well. All right, so both those are false now. This one is irrelevant. Render to file, we do want that exported, and I think we do want show preview window exported. So, yeah, okay. Let's try to run this and see what happens. Okay, so it's seems to have done something. Obviously, we're not rendering the scene yet, so we can't see anything, but it didn't crash, so that's a good sign. In fact, maybe we can go into scene.c and quickly just write out some information about what's there. So that we feel like we're getting something. So printf, adding scene member, and we're just going to put the type. This is going to be similar to that. So scene member, member pointer, I'm going to wrap this a little bit. And then here I can say kind. Yeah, so I just want to see what the kind is on that. Run it one more time. Adding scene member. Whoop, I missed it. Yeah, that's not a proper kind. Oh, because I'm not actually setting it. I need to set that in the variable when I create it. So did I only see that once? Because there should be two. Let me see. I may have written this loop wrong also. So as pointer current car. While is const current cooter, which should be fine. Let me see what's next. Yes, go back to these and set them up right. So this image make needs to set the kind correctly. Image member.kind equals scene. What is it? No, it's type image, right? Yeah, type image. Okay, adding scene member 1, but we're not hitting the next one, which is kind of weird. So let me think about that for a second. So scene member add, we're adding the scene members, fine. Then as const current cooter. So I'm trying to get to the next item in the list, which obviously is bad because I'm doing that before checking. Oh, and that even breaks everything. So, this loop is bad. I'm trying to think of a better way to encode the logic of this loop so that we don't end up with trouble here. So the idea is that I need to be able to do all the logic for this inside the loop. Okay, maybe it's just a matter of just doing something really simple and not dumb. How about this? Is const current. Okay, That's probably the right approach. So in here, I will say blah, 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 blah. Current is as const. Well, no. Can't really cast that for sure. And is const is looking for a value too, isn't it? What is members? Okay. Maybe that's the right way to do it. Members equals args2 or a pointer. Members. What don't you like about that? Ah, okay, sure. I don't want to copy that value. I don't think it makes sense to do that. So current, let's just leave that out for now. Is const. Nah, we need that. Value current member equals members. Okay, so is const current member. That should make that loop work. Obviously, it's not wanting to. Passing value star. Okay, I have to dereference that. Okay, and then I need to pull. I'll have to cast that. Well, no, I need to do more than that. So object const current equals as const current member. That's just terrible. Let's call it member. How about that? No. It's not right either. Const. We're going to call it const. How about that? As pointer const car. That's the member pointer. And why don't you like this? I also need dereference there. Okay, now object pointer is being pulled. Current is, excuse me. We're not going to do this as const because we're going to let the next loop through decide what to do on that. This also needs to be const. And I think that should work now. What are you not happy about? Undeclared identifier current. Is that current member? And then I'll make that a pointer to that const cell. Okay. Or a reference, let's say. Okay, now we have both scene members. That loop seems to be working correctly, which is good. So we've added both of those scene members to the new scene. So now we have a scene object that's been handed back to the mesh layer. We're getting close. So now once we have that, we just need to pass that into scene render. Now the problem is, I guess, I have to rewrite some of the rendering code in scene to use the new graphics APIs, but we can deal with that when we get to it. So scene render, what we need to do is make the renderer now use the new scene as current. So let's see, renderer scene set, maybe? Do that support exclamation points? We're gonna find out, I suppose. Renderer scene set. Scene. Problem is, how do we get access to the current renderer even? That's another wrinkle that I hadn't thought about yet. If we want to be proper with this, then we need to be able to get access to the current renderer without having like a global variable in C code. Having a global or having a module level variable in mesh code is not so bad, but in C code, not so great. But we can look into that in a moment. So renderer set scene, and that's pretty much it for that. We just need to go and wire that up in the renderer. So renderer scene set, or yeah, I need to get my APIs or my naming conventions dialed in a little bit here. Because we have things like, you know, scene render, graphics scene set. Let me see what I was doing before in graphics relating to scenes. All right, so Should I add scene flipping back here as an event to be handled? Well, we're going to need something like that, but we don't have it at the moment, obviously, as we were talking about in a previous stream. Let's see. All this stuff here is just sort of halfway written things. Render the test scene. All right. So here we're going to have a scene that needs to be rendered. And where do we have some globals? Static, scene, star, current, scene. Static, scene, star, next scene. And that's how we're going to do this. We're going to have a current scene that's currently being rendered. Actually, we don't even need the current here. We just need next. So when set to a value, this scene will be used in the next frame. Yeah. To do. Don't depend on a global. It's not really a global. It's a module scoped variable in C here, but still not great. Okay, so unused variable. Let's put that to nil to start with. And then back in the render function. Let's see, render the scene. We also need a current scene variable here. You can even say the current scene is null as well, because let's see, scene current scene equals null. So we're getting pretty close to having some decent abstraction going on here, where we have things that are going to be usable. Hey, Fade, is Twitch not working? Okay, let's see. Let me check on current scene, render the scene. All right, if current scene. First I need to check if next scene. Should we switch to a new scene? If next scene, current scene equals next scene, and then next scene equals null. And then render the scene. If current scene, then we draw that. We're going to get rid of these hack functions in a little while. If current scene, well, we're going to get rid of them if we make any progress here, which I don't know if we're going to end up getting everything done by the end. Okay, so for the scene library, scene, is there like a render function? What do I have for that? Okay, I don't think I have a good one yet, but we're going to add one. Flux scene render, and we're going to have scene star scene, and that's enough. Now we're going to go back to scene.c, and then add our render function. We'll probably put it above all this other stuff here. All right, so render scene. Cool. Let's just do this. We're going to sort of copy and paste some of the old code and then massage it a little bit. For int I is O, scene less than member count. Okay, so scene members I, kind is now the thing we're looking for. We're going to skip circle, but we are going to use image. Let's just leave that out for now. Render, scene render image. We're going to have a function called that. Static, we're going to make this module scope. We're not going to export this out of this file. So scene render image, that obviously needs to be a void. Scene, we need the scene that we're rendering into. We need the renderer as well. So let's grab the SDL renderer. What was I using for that? Let's go into graphics.c. Draw Flux window. Okay, and Flux render context. Fine. I wonder if Flux render context is not. Okay, no. Interesting. Some freaky stuff I didn't know I was doing. All right, so we're going to take this Flux render context, jump back into scene. We're going to have render context. We're going to have our scene. And then we're gonna have our scene image. Okay. Now you should be happy, right? All right, so now we should be able to render an image. Let's rip off some of the code we were using in the thumbnail renderer for rendering images. So we have some very overly verbose function names here that we're going to use. So we will take that and drop it in here. We probably need to also have the draw args object. Okay, we have that. Let's leave this out for now. Texture draw ex, context, image, texture. We need the texture. Is that okay? What's going on here? Incompatible pointer types passing flux texture. Oh, now I'm being bitten by some of my stupid typing decisions. All right, so let me go back to flux.h. Scene image has a flux texture that's not a pointer because I'm type defing the pointer type. Okay, we got to stop doing that because that's not good. Okay, so that's happy now. We also need the X and Y position that is specified for the image. So image, I think it's position 0, image position 1. Okay, I wonder if we're gonna get something on the screen here in just a minute. That'd be awesome if it actually worked. All right, so that's the context, the image position, draw args, which is not initialized. It might need to be initialized. We'll find out. In fact, how about we do this? Let's not even use the EX version of this. We're gonna use the non-EX version that does not require you to pass in draw args because we don't want to deal with that right now. All right, this should render the image in theory. We also need to pass in the render context. So let's just grab this right here and drop it at the front of Flux Scene Render. And that will allow us to pass our render context in. Here we need the context and we need the scene. And we also need to cast down that scene image from the scene members of I. All good? Okay. Hopefully all this typing stuff is going to work out in a second. Let's add a little printf here just to make sure. Rendering an image. Let's just make sure. Okay. So now let me double check this. I'm going to go back into flux.h, make sure that I update that signature. Flux scene render. This now has a new parameter. And then I'll go into graphics.c. Hey, Hider. Better late than nothing. Yeah. Indeed. All right. So let's go into graphics.c where we have that current scene. We should be able to do this, which is flux scene render. I think that the context variable is local to this function, so I need to use an ampersand context current scene, and that's it, right? Just need the context in the scene. What don't you like here? Ah, man, another one of these. Context. So every time we have a context, we can't use a pointer. It has to be just the object itself. Fine, okay. I really gotta fix that. At least that's correct. All right, let's try it out. Wait a second, we need one more thing. I think we need to have that function bound that can actually set the context or the current scene. We're super close. Hopefully we'll see something working in just a moment. So, what I was calling in thumbnail.msc was something called graphics scene set. Let's go to main.c and just bind that really quickly. So graphics scene set. Graphics scene set. I hope that this works. If it doesn't, I'll take the exclamation point off. Flux graphics func graphics scene set. Yeah, I know this is getting a little bit redundant with some of the naming here. The nice thing would be if we did not have to export these functions from the module, and I wouldn't need to use these nice little prefixes on them. So we're going to fix that also in a little bit. Well, maybe in the next stream we could do that. All right, so flux.ih, func. Well, let's go to the graphics section. Do we have any funcs here? We do have some funcs. Okay, let's just add this one in to the list. And this is going to be Flux graphics, graphics scene set. Okay. Then we're going to go into graphics.c. We're going to jump down to the bottom, paste that in. And then we're going to validate the parameter list, which is just a single parameter. Requires a scene to set. And then we're going to have object pointer scene pointer equals as pointer args 0. And then we can say next scene equals scene pointer pointer. And we want to cast that to a scene star. And we're going to say a little printf here. Or setting the next scene, I guess, is the appropriate way to call that. We're just, doing a little print there to make sure that this actually gets hit in practice. Next scene, what don't you like? When set to a no. Expected, what? Oh. I don't know whose fault it is. It's either CCLS or eglot. Things get out of sync a little bit. Which expression are you talking about? I'm going to compile anyway. This doesn't make sense. Okay, let's run it. All right, we got a little error here. Scene.c, line number 135. Oh, it's a pointer. Okay, so I do need to use a pointer there for kind. Is that all? Okay. Rendering an image. Okay, so at least it says it's rendering it. I don't see it doing it yet, but it says it's doing it, which is a good sign. So in scene render image, let's just double check what we're doing here. Printf texture is, I don't know what's in texture. Let's just check out image texture width. Hey, let's just say what the width is, just to see that we've got an actual texture loaded and it's not a bunch of BS. Okay, so that seems right. I think these are relatively big images. So both of these are loaded correctly, but I don't see them drawing anything, which is kind of interesting. The question is, why not? Why isn't it drawing the correct thing? Let's also check the position. Maybe the position is bogus. Position is D. No, this needs to be a double. So let's put in, what is it? %F, or is it like LF? LF. I don't remember what the specifier is for that. So we'll steal this. And also duplicate it. Oops. Okay, let's do that right there. Okay. Cool. Let's try that. It seems right. 0, 0 on one of them, and the right position on the other one. Okay. So why are we not seeing anything on the screen? That's kind of interesting. We're not seeing anything. Draw texture. Draw texture. It's just passing in null. Oh, okay. I didn't know that I had set that up. If args is not null, oh, the shader program. If shader program is null, shader program is 0. Yeah, okay. It tries to use the default, but I don't know if that's the right thing. So textured vertex, shader text. Let's check out, what did I do in the draw args? Here, draw args. And draw args. Scale, rotate. That's the render test. What about the render thumbnail? Shader program equals 0. Don't know why I set that. Unless it is meant to pull the default in. Draw args. Okay, let's try that real fast and see if that helps the problem. I think that the shader is not set correctly somehow. Okay, so let's take this print statement out. We don't need that anymore. And we're going to put this back to, let's get rid of that too. So draw texture EX, where we can pass in those draw args at the end and draw args. Okay, now let's try to render. Still nothing. That's really weird. I'm not doing anything differently. So let's go into that function maybe and see. Draw texture EX. I put shader program to 0. Default shader program is 0. Default shader program. I think this hasn't been compiled yet. So then it compiles the default shader program and then uses it. And that's the textured fragment shader, which should be the right one. Okay, rect vertex array, blah, blah, blah. So all that should be fine. So the question then becomes, what am I doing differently in the thumbnail rendering code? So let's just check this out really quick. If background, set the scale. I wonder if the scale is wrong. We can also try to set that too. Desired size divided by the logo width. Logo width? I think that's a bug. Draw arc scale, draw center false. Let's just, experiment a little bit. How about this? I'm going to throw this right here. Draw arc scale, center false. Let's just make scale be 1.5 F. 1.5 F. Let's just see what happens. Still nothing. That's really weird. It should be drawing something. Let me check graphics.c and make sure I'm putting this in the right place. It needs to be before the context gets flipped. Swap buffers. Flux scene render. Also, did I put any display inside of thumbnail.msc? Like, we're so close, man. It's really annoying if this doesn't work. Display, set current scene. I'm pretty sure this is working. That part at least. Yeah, set current scene. We're seeing that being printed out here. All that's happening the way it's supposed to. The texture is set. The position is set. Printf, switching to next scene. Let's just leave that there so that we can see that happening. Where does it say that? Switching to the next scene? Okay, so it is there. Current scene, flux scene render. So it's all down to what's happening in flux scene render somehow. It's really weird. I'm trying to think if there's any other possible explanation for why this could be happening. The texture data not being there, I mean, that's possible, I suppose. Oh. I think it's because of the thread that I'm loading the stuff in. I think that's the problem. I think that I'm loading the textures on a different thread than the OpenGL context, because the OpenGL context is running in a separate thread. So because I'm doing that, the textures are not being loaded in the right place, so they're not being displayed. I'm surprised it's not giving me any errors about that, though. That's really strange. So what was I doing about this before? Man, this is really annoying. So it begs the question, do I need to have some way to dispatch the actual loading to another thread and then send it back somehow, which is not good if I need to do that. The alternative is that the REPL and the engine need to be running on the same thread, which is something that I have been thinking about, but that requires that the REPL function be, well, yeah, maybe if I'm running this as a script, it doesn't need to be on a separate thread. But if it's the REPL, then the REPL needs to be running from within the render thread. And it needs to be asynchronously loading the, or reading from the standard in. I might have to make that happen sooner rather than later. That's unfortunate. So right now I don't have the ability to, what do we call it? Run this thing independently of the preview window, because I'm not creating a background window for image rendering. But it's something that we could do pretty easily, but we're sort of out of time now. So let me think for just 1 second about how I want to proceed here, if I want to do anything before we jump off. I feel like we made a lot of progress, though. Let me actually go back. Let me go back to the notes for the stream. So what do we do? Finish building out the functions, describe the full thumbnail. I mean, we sort of did that. I'm going to call that, you know, done-ish. These other things, though, we did not do. We weren't able to get to those, which is fine, because I think the more important thing is that we did manage to get the scene description stuff working to some degree, and it would render if it was set up the right way. So, just out of curiosity, see read from standard in asynchronously. Maybe there's a way to read characters without waiting. Okay, so there's this API that you can use apparently, which is a probably a kernel API, FCNTL. Both operating systems requested. All right, which would that be? Oh, Linux and OS X. Okay, that's fine. And probably it would work on MSys 2 also, I would guess, because that's probably going to be my compilation target for Windows for things like game development and whatnot. So you don't really have the ability to do like a fgets or something, but you could probably just write that yourself with this kind of thing. So you're basically reading into a buffer asynchronously. It's doing sleeps just to sort of pretend there's activity. So the way I would do this in the end is inside of the graphics loop. This would actually make it easier to do timed updates to things as well. So in the render loop, I would pull for events, and then I would probably read from the REPL asynchronously. That's not spelled correctly. No, chronously. Okay, and then whatever gets any fully formed expression would be executed there. So then if, let's say, the scene gets set, by the time we get down to this part of the code, it would pick up that next scene. So if we could read from the REPL asynchronously by having a function that could make that happen, then I think we could put all this on the same thread and not have to have a separate thread for it. And I was able to do that in Gambit's scheme. Gambit had the ability to read from a REPL on a thread that already had its own loop, its own busy loop going. So I think that's probably the solution, is to asynchronously read from standard in using that API that I just saw, and compile and execute the forms that are coming in through that as part of the loop. So that might be a thing for next stream if I don't implement it beforehand, because it's sort of annoying me now. So I might have to go ahead and just do it myself. And then next time when we come back, we probably will have the ability to do everything on the same thread. Everything will be rendering correctly, and then we'll have the ability to start, doing arbitrary images, at least rendering the images that we're loading, and then potentially adding the text to it. Text should be pretty easy to do after we get image rendering working. Then we can just describe the entire thumbnail with Mesh, as we've been waiting to do for, what, 2 months now? How long have we been doing these streams? Cool. So I'm pretty pleased with the outcome, aside from the fact that nothing is rendering. I know that it will render whenever it works, so I'm going to call that a win. And I'm also pretty pleased with how Mesh is coming along, because we're able to describe all this stuff in Mesh code at this point. Like, the compiler is doing all the work. As soon as module load paths are working, then I can move all this Flux graphics stuff into a separate file. And the thumbnail file will just have only the stuff necessary for describing the thumbnail, which is going to be really cool whenever that works. So I might have that implemented by the next time we're here. It depends on how much time I have available, so we'll see what happens with that. But at any rate, great day at Hacking Day. I really appreciate all of you who showed up and stuck around while I was, hacking through all this stuff. And we'll see you again on Thursday to continue picking up where we left off. So until then, keep it creative. We'll see you.